Hi, and welcome to this strange math lesson where we're going to be dialing in all about dilations. Yes, another section of transformations. Are you ready? Here we go. Strange, isn't it? Strange. Yes, that is the theme for today as we are talking about dilations. So again, we're looking at another type of transformation. And today, that transformation is called dilations. So we are going to be making things bigger and smaller. So bigger and smaller. And a couple of things to keep in mind is that this is one of the transformations that we would say is not rigid. So the shape and actually not the shape, the size will actually change. So the size will actually change. The shape basically remains the same, but the size is going to get different. So I want to show you in general what we're going to be doing. Imagine that we had this triangle, like or imagine, let's keep in the Marvel universe. Let's say we had one of those like really cool stones. Isn't it like 5 stones that Thanos has or something like that? Anyways, he has a stone. Let's say he has the green stone. And this green stone is really cool, right? And then there is a superhero that says, I'm going to somehow make this stone become bigger. And you're like, wow, you made it become a bigger green stone. Yes, and it became bigger. And you know what? I don't like that stone. Let's change the stone. We're still going to keep a green stone, but and you're going to see why I'm changing this stone a little bit. There. I like this stone better. So imagine we had this stone, and we're going to go and make it really big, and it's going to be like this. Whoa, what just happened? Well, we enlarged it. Okay, so this is the idea. Now, how did we go and do that? How do we go and enlarge this thing? So important to know is something called what the scale factor is, because we're going to enlarge things by the scale factor. And the other thing that we really need to know is, of course, the center of enlargement. So there are two things: the center of enlargement, and that's a big fancy way of saying where was the point that you started to enlarge it from. And how do you figure that out? This is how you figure it out. You take a ruler, and we're going to draw a ruler that's going to go through that point there. So it goes through this point, and it goes through this point. And then you get another color. Let's say another pink color. And you go through the other one. Hits that, and boom. So it went through this point and this point. And of course you get a third one. And let's see if this all works out. Oh, look at that, everybody. Rarely do I draw straight lines that actually turn out straight. And then you get this point here, and this is the center of enlargement point. From this point, everything enlarges. So let's just say we went and put some distances here. Let's start giving some things some names. We'll call this A, we'll call this A prime. We'll call this B, and we'll call this B prime, and C prime. Okay. And let's just say that we went and we measured everything. So we actually can go and measure. That's going to be kind of exciting. And we're going to say that, this distance here between, and we'll call this point O. Point O. So we're going to say OA. So say we said OA was 2. So that was 2 right there. But then OA prime, let's say, I don't know, it was 5. So like that, OA prime is 5. Well, then we could say that the ratio, like of there we go, OA prime to OA would equal 5 to 2. And we can use that to go and enlarge things. We say that the image is 5.5 times the corresponding sides, kind of thing. So we're going to start using the idea of scale factor and enlarging things. So that's kind of the idea of what we're going to be doing. Let's try some different examples with some different shapes. So imagine that we had a grid. So here's our nice little grid, and say it goes 1, 2, 3, 4, 5, then it goes 1, 2, 3, 4, 5. And let's say we just had a triangle. So we have a triangle at, so you have a point at, let's get a different color, 1 at 1, 1, say at 2, 1, and also like at 1.5, 2. 1.5, 2. Okay, so you have a little triangle there, woo, like that. And then let's say we said, and we'll call this like A, B, and C. So again, those points, there's 1, 1, there was 2, 1, and then up here was like 1.5, 2. Okay. And then we're going to say the scale factor. So this is where the scale factor kind of thing. So scale factor, let's start off nice and easy. We'll say the scale factor is 2. And we're going to say the center point, because this is really important. Kind of the center of enlargement. So where are we enlarging from? Is going to be the origin. Okay, so the center of enlargement is going to be right here. And we're going to make this all just bigger by 2. So if we're going to do everything by 2, where would the new A be? So if A was 1, 1, so remember here, let's go and just write this up here. So we said A was 1, 1. Well, now we want to go and enlarge this by a scale factor of 2. See how I'm enlarging? I'm doubling it, doubling whatever x is, doubling whatever y is. So what is 2 times 1? Well, that's just 2 and 2. So the new A, there's a different color, is going to be at 2, 2. Okay. How about the new B? So what would the new B be at? So if it was 1.5, 2, and I had to double it, it'd be at 3, 4. So that would be the new B. And what about C? It'd be at 4, 2. Right there. Like that. So now I've gone and enlarged it by a scale factor of 2. So it gives the idea of how this would kind of work. And then if you kind of look at it, is if you went through like everything, if we went and measured everything, be like kind of going through here, it should all hit the origin really nicely, like that. Again, my straight line's not as good, but that's the idea. So take the scale factor and then kind of apply it to the x and y coordinates, multiply it, and then redraw your image. And this is going to be enlarging things. But what about the opposite? Do you think that we could go and shrink things? I'm glad you asked. We can definitely do that. So here's another example. And just ask yourself, if you're going to go and shrink things, and make this 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have an image that we're going to go and dilate, but this time what we're going to be doing is actually shrinking it. So what would the scale factor have to be if you're going to make something smaller? Well, we're going to say the scale factor is going to be 1/3. And so the original image is going to be this kind of funky kind of, I don't know, should we have Star Wars reference here? What's the machine that the Jawas all go and work out of? So we'll say this is 3, 3, and this is 3, 6. And way over here, we'll say this is like 9, 6, some kind of like sand crawler or something like that, I think. And we'll say this is 1, 2, 3, 4, 5, 6, 3, something like that. So here we go. It reminds me of the little machine that goes and picks up R2D2 and C3PO. So like R2, here's R2, there's R2. There's R2, and then C3PO, which I think he's kind of boxy, isn't he? He's like an octagon. How many languages can he interpret? There's the question. I think he can interpret, what was it, 6 million? He doesn't have fingers like this at all. He is a protocol droid, of course. And then, of course, there's the Jawas. So the Jawas are those little guys, like, they go, ooh, doo, 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 like those guys, and they have like little yellow eyes that you can see in their little hoods. So those are my Jawas. These are horrible drawings. It has nothing to do with the math that we're doing. We're going to go and shrink this by 1/3. That's what we're going to go and do. So I'm going to go and shrink it by 1/3. I'm basically saying I'm going to take 1/3 of my x value and 1/3 of my y value. So I'm going to go and do that. What's 1/3 of 3? So I've chosen some nice numbers here, right? So 1/3 of 3's is going to be 1, 1. So this is going to be the new point. We'll call this A. We'll call this A prime. 1/3 of this is going to be like 1, 2. So 1, 1, 2. So it's like right there. 1/3 of this would be what, 2, 1. So something like this. And then way over there, 1/3 of that is going to be like 3, 2. So 3 and 2. So there's our new little thing that has going through the origin, of course, going through the origin of what that would kind of look like. And you can kind of see it going through there. Whoa, that was really bad. Let's try that again. That was still really bad, but that was the center of enlargement there. So using the scale factor is the key, and going and finding your different things when you're dilating, making it bigger or smaller. Thanks everybody for tuning in for another edition of Math with Mr. Douglas. Hopefully it was a marvelous time learning about math and dilations. Until next time, have a great day.